this problem says the line on the coordinate grid includes the hypotenuse of right triangle KLM. And there it is. And right triangle UVW is similar to right triangle KLM with a vertex W at the point 0, -2. The slopes of the hypotenuses of the two triangles are equal, and they want you to find the ordered pair that could be the coordinates of vertex V. There's quite a bit to unpack here, so let's take a look at everything that they're telling us here. Number one, they're talking to us about a right triangle. We have to know where the hypotenuse is. They do give you the clue here. It says the line includes the hypotenuse. So just in case you didn't know, they're telling you, so which is kind of cool. And the other way to know is I look at it as that right angle is pointing to the hypotenuse. It's always the longest side on a right triangle. And then we get to this point, it says the right triangle UVW is similar to this triangle. And similar just means that they're the same shape and all the angles are equivalent. So those angles are equivalent to these angles. It's just the size that is potentially different. Okay? Now, it gives us this vertex point, which we're going to plot here in just a minute, and then it says the slopes are equal. And when the slopes are equal, it either means it's going to be on this line or it's going to be parallel to this line. Okay? It can't be going this way. Okay? So, and we can actually look at this and tell what the slope is by looking at this right here. So, and slope is rise over run, which just means rise is just your y value and the run is your x value, because rise is going up and down, right? So from M to K is 2 and from K to L is 3 units. So this is our slope. It's a positive slope of 2/3. Okay, now it's telling us there's a vertex W at point 0, -2. So let's go ahead and plot that. And I'll put this as W. Now, one thing I also like to do, when they're telling you that there are two triangles that are similar, that means these letters are related to each other. So the letter related to W is M. So I'm going to put M in parentheses here, just so I know. It helps me to keep it straight. And then they want to know which ordered pairs could be V, could be the vertex V. And that V is here, and it's related to L, which is the other line or the other point on the hypotenuse. Okay? So L is going to be on that line. Well, look at this. Our point is already on that line. The only other place L can be is going to be on that line because everything else is a different slope, no matter what. Okay, so L is either going to be, to the right or to the left, but it's going to be on that same line. So we can use that information to go through and start checking these things off. So let's look at A. Let's use this. We have a point -6, 4. Let's go ahead and plot that point. -6, 1, 2, 3, 4. There's that point. Well, we know that's not right because we have a negative slope and it's not the same line, so it can't be A. Let's look at B. A 3, -4 is 1, 2, 3, and then 1, 2, 3, 4. Again, same problem. It's not the same line. It's not the same slope. Okay, and 0, 2 is the next one. 0, 2 is right here. Well, there's no slope there. And it's obviously not the same. Okay? So now D better be our answer, or we have done something seriously wrong. And that's 6, 2. Let's see. 6, 2. There it is, right on that line, which is what we expect. So now we can see we've got this triangle right here. And if you notice, this point here is actually K. That's the K point. So they are putting in information there that might be something you might do. Like this point K is a reflection of this point here over the x-axis, and then this point is a reflection of this guy over the y-axis. Okay, so hopefully that makes sense and this helped, and I will see you in the next one.